Good afternoon. Before I start the presentation, I want to thank the organizers for the opportunity to be here today. We're going to take a break from fire and talk about the ANSI APA PRG 320. This is the standard for performance-rated cross-laminated timber. And if you were in the Track A session earlier this morning, you heard the Smart Lam presentation. I promise there's not going to be too much overlap between this morning. Before we get into the actual standard, though, I want to take a few minutes to explain or to introduce who I am and the association I represent. So APA is a nonprofit trade association. We represent the engineered wood industry, manufacturers. All the products that we represent are structural in nature, so that means the wood structural panels in this day and age means plywood and OSB. We also represent prefabricated wood I-joist manufacturers, glue lam, cross-laminated timber, and then the structural composite lumber, LVL, OSL, and LSL. Some of you may know us as the American Plywood Association, but even before that, over 80 years ago, the association was the DFPA, the Douglas Fir Plywood Association, headquartered in Tacoma, Washington. But as southern pine plywood and other species of plywood came into the marketplace, in 1964 we became APA, the American Plywood Association, to better represent the entire plywood industry. And then more changes came. In the 1980s, OSB, the advent of OSB, which was helped and encouraged by APA through the development of performance standards, came about. And we're also talking about structural composite lumber and glue lam beams. So then in 1994, APA became the Engineered Wood Association. We kept it's not really an acronym anymore, but we kept APA really because of the brand recognition and the reputation of the name in the industry. We have over 166 members. They're scattered across North America. There's a few mills in South America as well. This map shows where our membership is located. We represent in excess of 70% of the industry. You can see in the bottom right-hand corner the percentages. So over 80% of the wood structural panels, nearly 90% of the glue lam in North America. So what do we really do? Well, our job is to promote engineered wood and the use of it. And we do that in really think of a three-legged stool. So one of the things that we do is product certification. So we have one leg of the stool would be the certification body of APA. This entails both testing and qualification, as well as ongoing quality assurance, etc. We also do a lot of applied research, and again, this is to help promote wood and protect wood in our model building codes. We also do a lot of research to help to try to make things easier for builders. If we can provide alternatives for builders, maybe they're more likely to use wood as opposed to other materials. And lastly, the third leg of the stool would be market access and development. And this is done in various ways, whether it's through code proposals. We're always at the code hearings. We have lots of publications which are on our website, which are all free. We also have a field staff that's scattered around the country that will help do trainings, seminars, webinars, etc. So quickly, there's more details on our website, but APA carries numerous certifications both in North America and internationally. These are maintained by our Technical Services Division and our Quality Services Division as both a testing laboratory and a certification body. In terms of applied research, our flagship lab in Tacoma, Washington has over 42,000 square feet of testing area. We have done projects as big as building a full-scale house, and we looked at different bracing methods and different sheathing to see how it would perform. We also have the ability of doing combined shear and uplift of walls where we're applying both lateral and vertical loads at the same time. And these loads can be static or cyclic in nature. We've done diaphragm tests. This diaphragm test is 24 feet by 24 feet, so this would be a floor or a panelized roof assembly. This was done for our I-joist members to demonstrate the applicability of using I-joists as the predominant framing members. And of course, we're starting to test CLT. It's important to note that we are driven by our membership. And again, I just want to note that the Field Services Division within APA is comprised of about a dozen staff that are located strategically around the country, most of which are architects or engineers, and they will do trainings, they'll attend trade shows, anything to do to really help promote wood. I'm not going to go through this whole list of summary of services, but again, I just want to reiterate, we strive to be a one-stop shop. We try to aid in our membership's testing, certification, and promotion. So I guess the real first question about PRG 320 is why is a standard necessary at all? And the answer is probably fairly clear. We need standards in order to facilitate acceptance in the marketplace. The interesting thing about PRG 320 is that it's not an APA standard. APA is in the title, but it's an ANSI standard. It's ANSI/APA PRG 320. By definition, an ANSI standard is consensus-based. So I'm probably going to harp on this too many times, but APA did not write this standard. We help promote it, we help organize the meetings, but this is truly a consensus-driven standard. Now, what's the importance of a consensus-driven standard? It's going to get into the code easier. This ANSI standard, it has to be comprised of a balance committee, and it goes to public vote and comment. So if it passes, which this did, one would assume that it's going to be recognized by the model building codes without controversy. A product standard will also help with consistency in both product quality and therefore design, as well as safety. Think of it almost as a level playing field. Commodity standards, in particular, I would argue, can improve product availability. And by commodity standard, I mean that there's only a select number of grades, which is not to say that PRG 320 is restrictive in any way. What I'm trying to say is that if there's a limited amount of grades, it makes the work of designers easier. It standardizes things in a way. That would allow the designers to focus on design, innovation, without having to track down spec sheets and design values. So here we are, ANSI APA PRG 320. APA initiated the development of this standard in 2010. It was approved in the next year, in 2011. Again, it's an open process. There was 35 voting members and also 22 observers. Voting members were comprised primarily of North America, US and Canada. There was one member from Europe. We also had some observers from Australasia, so it was truly a global effort. Again, ANSI committees need to be balanced. That is a requirement, so our committee was made up of manufacturers, suppliers, users, etc. The standard is intended to cover all of North America, both the US and Canada. However, if you get into the meat of the standard, you will note that requirements do differ depending on where the product is to be used. In terms of contents, there's essentially 6 components of the standard. This reads pretty much like any other performance standard you may have seen. There's requirements for dimensions, tolerances of those dimensions. We have separate sections for requirements of the individual component of a CLT billet or panel. There's defined performance requirements, references to the test methodology to qualify the product. There's sections on quality assurance and trademarking. And again, I'm not going to talk about quality assurance. That was covered quite extensively this morning. Some of the key considerations of CLT panels produced under the standard. CLT panels are considered to be for dry use applications. 320 is defining this as 16% moisture content, equilibrated. Under this scenario, everyone understands that panels and billets may be exposed to moisture during construction delays. That's covered under dry use, but in no way are these intended to be used for exterior applications unprotected. The lamina can be lumber. We assume 12% moisture content, or it can be SCL, structural composite lumber. If structural composite lumber is used, it is assumed that that material has already been qualified under a separate ASTM standard, D5456. Essentially, any softwood species can be used under 320 as long as the published specific gravity is 0.35 or higher. In essence, that covers all commercially available lumber. There are requirements on layups. The outermost layers need to be visual grade number 2, or if it's MSR graded lumber, then it needs to be 1200 FCB 1.2E. Core layers, the minimum is simply visual grade number 3. There's also restrictions on lamination thickness. Lamination thickness can be 5/8 of an inch to 2 inches. And there are also criteria on lamination width for parallel layers, where you can use a 2x3, but for the perpendicular layers, we can't really exceed a minimum of 2x6, and that's due to the interlaminar shear and creep considerations. I'm going to show you some pictures later on of some interlaminar and also rolling shear. But there's always caveats, isn't there? For every rule, there's an exception. We can deviate from this if it's tested. So let me back up and just kind of reiterate that just one time. So PRG is both prescriptive and performance. There are some prescriptive layups in there, but if you want to deviate from those, that's acceptable as long as you get approval by your approved certification body and agency, and you go through the testing that's called out in the standard. CLT thickness of the panels is 20 inches at this time, and again, there's some tolerances on dimensions. And when this standard was developed, it was assumed, and I think it's still assumed, that most CLT manufacturers are going to have started in glue lam beams at some point. So there's a lot of references to glue lam test methods and standards. PRG 320 requires that the adhesives used in CLT for the US meet AITC 405, as well as a separate heat performance test. Now, this PS1 is a plywood performance standard. The heat performance test is actual exposure to flame. After a given time period exposed to flame, the specimen is broken apart to look at delamination, see if there's any delamination. What we're really trying to find out here is if the adhesive is disappearing, if it's being burned off by the heat or the fire. In Canada, the requirements are slightly different. We're referencing CSA 0112.10, as well as the ASTM heat durability standard, and again, that plywood PS1 heat performance test method. As was noted in a separate session this morning, there's no, edge joints are not required to be glued together. It's been shown that edge glued edge joints do not provide any structural enhancement. So the adhesive requirements that I'm talking about are for the end joints, finger joints, as well as face bonds. So here's more of the prescriptive part of PRG 320. The standard lists 4 E-rated grades. E would be MSR lumber. And you can see, I'm not going to bore you with this, but each grade is defined by both the lamina grade as well as species. There's also 3 visual grade CLT billets, differentiating in terms of species groups and grades. There's also appearance classifications. They're in a non-mandatory appendix. So those 7 different prescriptive layups in the previous slide, there are published stresses for those layups in 320. Now the stresses are to be used with the section properties that the CLT manufacturer supplies to the designer. But in a couple tables, we also publish capacities. So design capacities for those grades. And for the engineers out there, these properties, the stiffness properties were designed using the shear analogy model, which is thought to be the most precise model for those calculations. But again, other models can be used if accepted by your approved agency. Note, I don't know if you can see this here, but the capacities are limited to bending at this time. Tension, shear, compression capacities are being developed and are expected to be included in the next version of the standard. So are you limited to those seven grades? Of course not. It's impractical to list every single combination out there. So a custom grade, which I'm sure there's going to be many, is permitted as long as you follow the steps within as long as you follow the steps in the standard in terms of making sure your adhesives are approved, you follow the pre-plant qualification as well as the mechanical properties evaluation testing. We have a nice cheat sheet in the standard. This is a quick table to see what you need to do to get your product stamped 320. Again, we've talked about lumber and adhesive requirements and assumptions. And then we need to do what's called in the standard plant pre-qualification. Again, here we're referencing some AITC standards, CSA standards. And what we're looking for, really, the plant qualification is really to demonstrate adequate bonding. So we're using block shear methodology. We're using accelerated aging techniques, vacuum pressure soaking, to make sure that the adhesive bonding is adequate. What we want to see is failure within the wood, not failure at the adhesive bond line. And these slides here actually represent some fairly extreme examples of inadequate bonding. The glue it's white glue, so it may be hard to see on the screen, but we don't see a lot of wood pull. That's indicating that the failure is within the adhesive itself, under shear. And on the rightmost, you can see the delamination after some accelerated aging techniques. Once we see results that look exactly opposite of what I'm showing here, we consider the plant to be qualified for bonding, pressing. And once that's done, we'll do some verifications of the analytical model in terms of mechanical properties. We're looking at bending and we're looking at shear. The bending it's typical ASTM bending, third point. The span of depth is 30:1. That's to ensure that we're actually going to get some bending failures and not shear. The shear tests on the right, those are done on a short span to induce again, to make sure we induce shear. And the standards are your typical ASTM standards for short span bending as well. So we're not trying to invent the wheel. We're not trying to come up with any new test methodologies. We're using existing tests out there that are primarily for beams, glue lam, and applying them to CLT as best we can. So here's what some typical failure modes might look like. These were taken out of our laboratory. On the right top and on the left top and bottom, those are the bending tests. You can see that, especially in the top left, we're seeing some failures in tension like we want to see. The failure mode can propagate along lamina, in between lamina. On the right is some typical shear failures. You can see some both interlaminar shear and some rolling shear within the lamina. So products that are qualified under 320 need to be trademarked as such. So these are trademarks that APA has issued to one of our member companies. So these are typical trademarks that would include a trade name, our logo, our certification body logo, the grade, dimensions, the plant number, and the standard. Fairly typical trademarks you'd see in the marketplace for other products. Once that's done, you will probably going to see some sort of evaluation report or product report. This is an example of an APA product report that we provide to our membership for a small fee. It's going to contain a lot of the information that you'd find in an evaluation report. It's going to have product description, design properties, installation guidelines, etc. So the second bullet point is kind of the key message here, apawood.org. That's our website. The most current version of the standard was published in 2012. You can download it for free. And I guess the other thing that I want to note about our website is that because this is an ANSI standard, it's required that this gets reevaluated periodically. ANSI standards need to be reevaluated every 5 years. So we're looking to have the next version published in 2017, which means the work is really going to start happening this year, in 2016. If you go to our website, there's a web page dedicated to PRG 320 where you can find all of the previous committee ballots, meeting minutes, etc. You can also, if you want to apply to the committee, you can download an application form there. So I guess the take-home message in regards to that is that this is a living, breathing document, which I'm sure will change over time. And we'll wait for questions at the end. Thank you.